Hello guys, welcome back to the universe of TechHub. In this tutorial, we will learn about DFS, Depth First Search. In this tutorial, we will learn about Depth First Search Algorithm. In Depth First Algorithm, first we need to learn what is Depth First Search. The DFS is a traversal techniques which involves the idea of recursion and backtracking. DFS goes in depth, traverses all the nodes by going ahead, and when there are no further nodes to traverse in the current path, then it backtracks on the same path and traverses the other unvisited node. This is all about what is DFS. DFS is a depth first search. We pop from the stack when we need to backtrack. When we finish exploring a node and all of its adjacent nodes, the process of popping from the stacks happens when we need to return the previous node to explore its other unvisited adjacent nodes, if any. Next, DFS explores as deep as possible along a branch. Before backtracking, it uses a stack or recursion to keep track of nodes and backtracks when it reaches a dead end. Next, how it works starting from the source node. And DFS goes deeper into the graph, visiting one branch of the graph first before backtracking to explore others. This is the what is DFS. Next, we move on to the when to use DFS. We are using in the DFS like exploring all the paths and backtracking problems and memory efficiency, and also using tree traversal like pre-order, post-order, in-order traversal, and backtracking problems like puzzles, detecting cycles like that, and also using it in performing a topological sorting in a graphs, and also used in maze solving and finding connected components in the graph. These are all the when to use DFS. Next, what are the applications of DFS? In DFS, cycle detection in graphs. These are also applications of graphs and finding the connected components in a graphs and solving a puzzles like Sudoku, like that. And also used in topological sorting in directed acyclic graph and finding strongly connected components, and also solving maze solving and web crawling and tree traversal like a pre-order, in-order, post-order, and pathfinding in games. This is all about applications of DFS. Next, we move on to the algorithm. In algorithm says set status 1 ready state for each node in G is graph. Push the starting node A on the stack. Set its status 2 waiting state. Repeat step 4 and 5 until stack is empty. Pop the top node N and process it and set its status 3 processed state, and push on stack all the neighbors of n that are in the ready state whose status is equal to 1 and set their status is equal to 2 waiting state. End of loop. This is how DFS works. Means it's the first start at node A. Push A to the stacks. Next, pop A and mark it as visited and push its neighbors B and C like that. These are all the how DFS works. And advantages of using a stack is it is a recursive DFS without using a function called stack. This is the advantages, and prevent the stack overflow for large graphs. That is also reason for we need to use stack. I'm taking one example to shows how DFS traversal works. This is the example how DFS works. First, it visits the. Here is the example how DFS work. First, visit the node A and mark as A visited. Add a node to the stack. And next, A neighbors are E and C. I am taking a C and mark node as C and push to the C to the stack. Next, node A is already marked, and next we move on to the process C and B. Print and call the depth first search of B, C. The C neighbors are D, B, and F. We need to take B and mark the node as B visited and add the B to the stack. Next, we move on to the B neighbors are C, F. So we need to take F. F as visited, mark as visited. Next, we need to push to the stack. Next, node B is already visited. The F adjacency or neighbors are E, D, C, and B. C and B is are already visited. We move on to the D. We need to mark as D as visited and push to the stack, and mark as D as visited and push to the stack. Next, we another one is F. And F is already visited. So the D neighbors are C and F. So we need to C and F are already visited. So we need to pop the D. Next, we need to process E. Call the depth first search and mark as E as visited and push to the stack, push E to the stack, and no is and E's neighbors are A, C, F are the neighbors of E. So A is already marked and F is already marked. So we need to pop E. So next we need to move on to the F. We need to pop F because all neighbors are already visited. Next we move on to the pop B. All neighbors of B are visited. So we need to pop B. Next node E already marked. Next F is already marked. Next we need to pop the C because C neighbors are already visited, so we need to pop the C. Next we need to node E already marked and pop A of the star. It is a complete depth first search graph. Next we move on to we are taking one example to how depth first search works and implementing using a Python programming language. First we need to take function definition dfs of graph comma start node. Graph is the adjacency list representing the graph. The start node, the node where DFS begins. Graph and start node as the parameter. That's the reason why we need to use the graph and start node. Graph is the adjacency list representing graph, and start node is the node where the DFS begins. Next, we need to initialize the stacks. Stack is equals to open bracket and close bracket, open braces and close braces. Stack dot append start node. DFS uses a stack to keep track of nodes to visit. It ensures a last in first out or first in last out. Stack follows the principle of first in first last out or last in first out. Next, we need to take append stack dot append of start node. Add the starting node to the stack to kick start the traversal. That's why we need to write stack dot append start node. Next, we need to write visited set. Like visited is equal to set function. Tracks the visited nodes and it also avoids the infinite loops in a cyclic graph and prevents the redundant visits to the same node. Next, we coming into the DFS main loop. This is the code for DFS, DFS logics. While stack, why we need to while using a while? As long as there are nodes in the stacks, DFS continues exploring the graph. That is why we need to use while stack. Next, the current node is equal to stack.pop. It removes the last added node from the stack for processing. This is the core of the LIFO behavior of the DFS. It means LIFO means last in first out behavior of the DFS. Next, we need to process the node. If current node not in visited, print current node end. Next, process the node. Visited that add current node. The condition if current node not in visited, it ensures the node is processed only once. Next, actions. The print the current node and process the node. Adds the node to the visited set and process it. The printing the current node. Next, We move on to the push the unvisited neighbors. These lines are the push the unvisited neighbors. Like for neighbor in graph current node, if neighbor not in visited, stack dot append neighbor. It iterates through all the neighbors of the current node. If a neighbor has not been visited, it's added to the stack for future exploration. This is why we need use for loop and if loop for neighbor in graph current node. If neighbor not in visited, stack that append neighbor. If a neighbor has not been visited, it's added to the stack for future exploration. Next, we move on to the right to graph part. Graph is equals to in adjacency list, representing the adjacency list, we need to use curly braces. A adjacency are B and C, and B adjacency are D and E, and C adjacency are F, D adjacency are nothing, and B adjacency are F, F adjacency are nothing. Next, we need to print DFS traversal. Then I need to call DFS function graph comma A as the starting node. That's why we need to write A. This is all about the Python program implementation. After running this code, we need to get this output DFS traversal A comma C F B A C F B E D. First it visits the A and next it visits the C F B E D. This is all about how DFS works. Hope you guys understood. If you like this video, please don't forget to subscribe, like and share and comment in this video.